Welcome to another episode of Math with Mrs. Wilson. This is section 8.8, and we're using the complex number system. By the end of this section, you'll be able to evaluate the square root of a negative number, add and subtract complex numbers, multiply complex numbers, divide complex numbers, and simplify powers of I. I is the letter that we use for imaginary numbers. It's not a variable. It actually stands for the square root of -1. So for example, the square root of -16 is the square root of 16 times the square root of -1, and that would equal the square root of 16i, or 4i. Let's look at what we have when we're adding and subtracting complex numbers. Well, remember that we can only add if we have like radicands or radicals, and I can split -32 into -8 and 4, and I can take the square root of 4, which is 2. So this is also -8, the square root of -8, plus 2 square roots of -8, so that equals 3 square roots of -8. But we can also write that -8 as -4 times 2, or actually, why don't we make them all positive, and then times it by a -1 to get the negative. So then the square root of 4 is 2. So we have 3 times 2. Then we have square roots of 2. And then instead of writing the square root of -1, we're just going to put I. So that equals 6 square roots of 2i. Now we'll have you go up to the boards and work on the try it. Now you can check your work to see how your group did. Let's look at the next problem. We have 2 plus 3i plus 6 plus I. We can add the 2 and the 6 because of the associative property of addition, so 2 plus 6. And we can also put the 3i and the I next to each other. So this becomes 8 plus 4i. We could factor out F4, but that's not necessary. All right, go ahead and do the try it. And you can check your answers. Now we're going to subtract, and when we're subtracting parentheses, we need to make sure that we're subtracting each piece, and so I like to rewrite it as adding the opposite. So we have 3 plus 5i. I'm going to change this to adding, and then what's in the parentheses changes to opposite, so -1 and -2i. All right, so 3 minus 1 is 2, and 5i minus 2i is positive 3i. Go ahead and do the try-its in your groups. And you can check your answer. When we're multiplying complex numbers, something happens with the I. So we're going to distribute here. We have -2i, and we have plus 6i squared. Well, let's think about I is equal to the square root of -1, but I squared is the same as the square root of -1 times the square root of -1. But we can just simplify that to -1 because the square root of something times itself is itself. Okay? Then here we have negative 2I plus, instead of I squared, we'll put in parentheses negative 1. I'm going to simplify that. So we get negative 2I minus 6. And then standard form is that we would write that in the other order. So negative 6 minus 2I. Go ahead and do the next one in your groups, and then we'll come back. And check your answer, and then we'll do the next one. We have one that we need to distribute. So negative 5 times 2 is negative 10. And then we have negative 5 times negative 3i is plus 15i. 3i times 2 is plus 6i. And then 3i times negative 3i is negative 9i squared. Let's simplify this. So we have negative 10 plus 21i minus 9, and we'll change the I squared to negative 1. All right, so negative 10, and then this is going to be positive 9 when we multiply, so negative 10 plus 9 is negative 1 plus 21i. I'll pause the video so that you can do the try-its in your group. Take a moment to check your work and then turn your page. For these examples, we have a binomial squared, and so that's going to be expanded as 2 minus 3i times 2 minus 3i. We can use the perfect square trinomial. So a squared, that's going to be 2 squared. It's a minus, so minus 2 times a times b plus b squared, which is 9i squared. Simplifying, we get 4 minus 12i plus 9, but instead of I squared, I'm going to put negative 1. So 4 and negative 9 are like terms. That's negative 5 minus 12i. And then I'll give you a chance to complete the next one in your groups. So go ahead and check your work. I also put in the formula for perfect square trinomial in case you needed it in your notes. Moving on, we have a complex conjugate. You've seen this word before. Conjugate pair is of the form a plus bi and a minus bi. When we multiply conjugates, they are differences of squares. So a difference of squares looks like a minus b and a plus b. When we FOIL that, we get a squared minus b squared. So let's square a. We have 4 squared minus 3i squared. 4 squared is 16 minus, this will be 9i squared, which is the same as 16 minus 9 times negative 1. So that changes to 16 plus 9, which equals 25. We took complex numbers, and now we have an answer that's a real number, and that's because it's a complex conjugate pair. Let's do one more together, and then I'll let you do the try-its at the board. So we have negative 2 squared minus 5i squared. It's important to put it in the parentheses because I actually made a mistake and had to redo the part of the video because you have to square both the 5 and the I. Negative 2 squared is 4 minus 25i squared, or 4 minus 25 times negative 1. And that becomes 4 plus 29, or 25, which is equal to 29. go ahead and do the 2 try it problems with your group, and then we'll come back and check the answers. All right, so that is multiplying complex numbers. Now we're going to talk about dividing complex numbers. So it tells us to use the conjugate. We use the conjugate, we multiply by 5 plus 2i in the denominator. So then in our denominator, if we use differences of squares, we get 25 minus 4i squared. And we'll need to distribute the numerator. So that's 10 plus 4i plus 25i plus 10i squared. Okay, let's simplify that. And when we simplify, we're going to get 10 plus 29i plus, instead of 10i squared, I'm going to put 10 times negative 1. That cancels the 10, so I'm just going to carry my denominator down. 25 minus 4, instead of I squared, I'm going to put negative 1. I can keep simplifying. So in my numerator, I have just 29i. In my denominator, I have 25 plus 4, which is 29. So the whole thing just simplifies to become I when I divide it. See if you can do that in your groups with the next problem, and then we'll come back and check it. And you can check your work. Now we're going to go step by step by step. Dividing 4 divided by 1 minus 4i. The first step tells us that we multiply the numerator and the denominator by the complex conjugate of the denominator. So we have 4 over 1 minus 4i. We're going to multiply it by the conjugate. So 1 plus 4i. Then we're going to multiply the numerator and use the product of complex conjugate pattern in the denominator. So in the denominator, we just have 1, and then it would be negative 16 times I squared, which is simply plus 16. Then we can distribute, we get 4 plus 16i. So when we simplify this, we get 4 plus 16i over 17. To write this in standard form, we just split it into 4/17 plus 16/17 I. And that's the standard form. When you're ready, turn the page. I'll have you do the try it, and we'll come back, and then we will do the last 2 problems. Go ahead and check your answer, and then let's move on to the next example. In this case, we have a complex number in the denominator again, but there's nothing to do the conjugate with, so I'm just going to multiply by itself, 2i, and see what happens. Okay, so we'll distribute, and we get 6i plus 6i squared over 4i squared. We could divide out a 2 here and just have 3i plus 3i squared over 2i squared. And remember, the I squareds are just negatives, or negative 1, so 3i minus 3 over 2 times -1 is -2. Now I'm going to write that in standard form. So the I comes last, so it would be -3 over -2, which is just 3 over 2. And then we would have minus 3i over 2. And then the I goes in next to the fraction like so, instead of in the numerator. All right, go ahead and try the next problem, and then we'll write our summary as a class. Thank you for watching Math with Mrs. Wilson. Don't forget to like and subscribe.